Hello, my name is Andrei Smirnov. I'm from Ster Labs, and today I'm going to talk about Talos upgrades. We'll start with some basic information about upgrading Talos, and next there will be a live demo of the cluster upgrade. So, why upgrading an operating system? Because new versions add new features and also contain security fixes. So certainly it's important to upgrade the operating system. And Talos is the operating system which makes upgrades really easy. Let's look at how this is accomplished. First, let's start with the very basic system disk layout. So Talos is installed to some system disk, which is a block device. And if we simplify the disk layout, it consists of three partitions. One is the boot partition, which contains the Talos image. Next is the state partition, which holds the node configuration data like machine configuration, node identity, etc. And last, the majority of the system disk space is actually allocated for the ephemeral partition, which is mounted as /var, is the only read-write location on Talos system disk, and that usually holds container state and other ephemeral data. What happens on upgrades? So on upgrades, the boot partition will be replaced with the new Talos image. As Talos image is immutable and read-only, replacing the image completely upgrades the operating system. The state partition will be preserved, so the machine configuration will be same as it was before. And ephemeral partition by default will be wiped. So the node starts from a completely fresh state, and Kubernetes will be able to schedule back all pods and containers which were running on this node before the upgrade. The upgrade sequence looks like that. We start with draining the node. So the we don't schedule new workloads on the node, and also we try to remove or move away all the pods which were running on the node to other nodes, so that before the upgrade it is completely empty and the upgrade process itself doesn't affect the workloads. Next, on control plane nodes, we're going to leave the etcd. The reason is that the etcd data directory lives on ephemeral partition, and as that is going to be wiped, we need to make sure that we can uh, that we leave the etcd so that this data is going to be recreated when the node joins back the etcd cluster. So this only works, of course, if you have HA control plane. So you need to have a minimum of 3 control plane nodes for this flow to work. But if running single control plane node, which is not recommended, there is a flag to the upgrade command to preserve the ephemeral contents. In this case, the upgrade can be safely done on a single node control plane, but certainly it is not an HA scenario. After that, Talos stops everything, wipes the disk, installs the new Talos image, and reboots. On reboot, the Talos boot is normal. So if it's a control plane node, it will join back the etcd cluster. If it left, of course, on upgrade, then it will launch all Kubernetes components, and the kubelet will register the node back, and the workloads will be scheduled once again by Kubernetes on this node. Some tips on upgrading. When upgrading, it's usually better to upgrade nodes one by one and to make sure that there are no undesired effects or some bugs which might be uncovered by the upgrading. If you run complex orchestrated workloads like Ceph, Rook, it also makes sense to make sure that Ceph is healthy in between the upgrades. Um, Talos itself is going to wipe only the system disk, so the other block devices which are used for Ceph, Talos is not going to touch them, but Ceph still needs some time to get up and running after the upgrade. Plus, like for example, some additional data might be stored on ephemeral partition, and even though Ceph can successfully recover from a single node failure, like what Upgrade does by wiping a single node, you need to make sure that Ceph is healthy before moving on to the next node. And of course, upgrading Talos doesn't mean that everything is upgraded. Don't forget about upgrading Kubernetes as well. So let's do a live demo of an upgrade. Uh, so here, here I have a terminal where we're split into three parts. In the upper part, on the top, I have a regular terminal. The middle part shows the output of kubectl get nodes. So I can see that I have a cluster of 5 nodes, 3 master nodes, control plane nodes, and 2 workers. They're all running Talos 0.13.5 at the moment. And the bottom part of the terminal shows the serial console logs coming from all servers combined. So to start an upgrade, I'm going to use the Talos CTL, which is a CLI tool. I'm going to point it at the first node, the first control plane node, and run the upgrade command specifying the image. So every Talos release, we publish an image, installer image, for each version of Talos. So I'm going to upgrade to the latest 0.14 release, which is 0.14.1 at the moment. And this is how my upgrade command looks like. I'm going to upgrade and I give an image reference. So when I hit enter, what you can see in the bottom part that Talos started to pull down the installer image. It pulls it down from the container registry and is going to validate to make sure that's a valid installer image. And after that, it will kick off the upgrade sequence. The installer image contains everything which is needed to run Talos. So what was happening, it actually has drained the node already and now stops everything, stops every container, removes every pod on the system to make sure that we have no processes running left on this node. Then it's going to unmount all partitions, wipe the disk, and install new Talos version. So it takes a couple of seconds to get, and you can see that it's actually left etcd, wipe the node, install new version, and reboot it. It's actually doing that faster than I can speak. So by this time, it's booting a new Talos version, putting up all the services. And once they are all up, and you can also see that etcd joined back. And on the kubectl get nodes output, you can see that node became not ready. So Kubernetes noticed that kubelet wasn't running, but now kubelet is running back. Node is back into ready. It's still scaling disabled. It's still cordoned. It will take a bit of time for Talos to boot and uncordon the node. And now you can see it's running Talos 0.14.1. And that's basically it. So at the moment, all the components are up. The control plane, I had an HA control plane of 3 nodes, so even though my first node was going through the upgrade, other nodes were working. So I didn't have a time when the control plane was down ever. And I can proceed with the upgrading the second node and so on. So the second node, then the third node, fourth, until I upgrade all nodes in my cluster. If that was a real production cluster, I need to make sure like my services are healthy. This is a test cluster I have, so I don't have anything to check for, but it still shows the basic upgrade process. I'm going to, so the upgrade process doesn't much on the node type. The control plane nodes, they take a bit more time to be upgraded because they might run more components or you have to leave etcd. But at the same time, there is no big difference. So the second control plane node, it went through the same sequence. It left etcd before upgrade. It wiped the data. Now it's booting back up, and etcd is joining back the cluster. So the number of members in the etcd cluster is 3, as I have 3 nodes, but during the upgrade, it goes down to 2 nodes. And then after the upgrade, it's back to 3. So it still has enough nodes for quorum. And you can see that the second control plane node got updated to the new Talos version. And you can see that the kernel got upgraded and containerd was upgraded as well as part of that. Then I can move to the last control plane node. And at this, once that is done, my control plane will be fully upgraded and I can do the upgrade of the worker node. The serial console is an easy way to follow an upgrade. And of course, upgrade can be completely automated as everything is happening over the API. So we can send the API request to upgrade the node and wait for the node to be upgraded to come back up. And once it is up, we can wait for it to boot and perform any additional checks that might make sense for a specific workload or specific Kubernetes cluster. And to make sure that it's safe to upgrade to move on to the next node. Okay, looks like the third control plane node got upgraded. And I'm going to move on to the worker nodes as soon as this is fully done. We can also check the etcd membership status just to be sure that everything is fine. So we can see that we still have 3 members as expected, even though during the upgrade they all left etcd and then joined back. What might be like a good thing to do during the upgrade is also to take the etcd backup before upgrading, just to be on the safe side. Talos upgrades are safe or designed to be safe, but extra safety measure is never a bad idea. So all my control plane nodes are now running new Talos version, and I can proceed to worker upgrade. Worker upgrade procedure is exactly same. The only difference is there are a bit less steps, so it's a bit more simple. But besides that, the process is completely same. You can say that immediately as I start the upgrade, Talos cordons the node, so it disables scaling new workloads and also tries to drain any workloads which are still running on the node. Whatever can be moved away will be moved away. And once these are moved away, it moves on to stop and remove all running pods. This is required to unmount, like I said already, any file system available. The test I'm showing here is running in virtual machines. My test cluster is running in virtual machines. But what is interesting about Talos, if you notice that in the serial console log, that is using kexec to reboot to new Talos version. So it means that it skips the BIOS boot sequence completely, which means that on bare metal, this upgrade will be almost as fast as we can see it right now with the virtual machines. Usually it takes more time for the Linux kernel to boot on especially bigger bare metal boxes when there are lots of devices to discover. But as I was speaking, my fourth node got upgraded to 0.14.1, and I can move on to the last node in this cluster. And as you can see also during the upgrade, the control plane was completely up and available. So because this common kubectl get node, which is running here, never failed. So there was no interruption to the control plane, Kubernetes control plane APIs. And the workloads, if we were talking about real cluster, would be moved from one node to another as they get upgraded. So certainly this upgrade procedure should be safe to run in general, even on production cluster, without like any significant downtime, if any. But that depends more on the workloads. Usually workloads will be moved safely, so there will be no downtime if the cluster is designed to be HA. So let's give it a couple of seconds and my last node should be all upgraded and ready. You can see it already updated the Talos version and it should like take a couple of seconds for the node to be uncordoned. So Talos upgrades are safe, are easy to run, and also as Talos is self-contained in that image, that means that the upgrade takes care of upgrading everything. The Linux kernel, containerd version, etcd version, if that is included in the upgrade. The only thing which is not upgraded by default is the Kubernetes. And Kubernetes upgrades are going to be covered in a separate video. That's all I have today. If you have any questions, please feel free to reach out to us. Thanks for watching and have a great day.